Hi dear students, in current electricity, in the previous video we have discussed some important questions. In this video also we are going to discuss certain important questions. Please go through it, and within 48 hours you are going to write examination. So tomorrow also is very important day for us. I will explain some of the very important questions in the tomorrow itself. Please go through it and write and face the examination very confidently. I wish you all grand success. So in the video what we are going to see first is internal resistance of a cell. ஒரு செல் கொடுத்திருக்காங்கன்னா அதோட internal resistance எப்படி calculate பண்றது is very important question. See, here we have a cell of electromotive force epsilon. Its internal resistance is R. So when this cell is connected to a voltmeter in series, so that is the first diagram. So you know very well the resistance of the voltmeter is very high, right? The voltmeter will offer very high resistance, so the current will not flow through the circuit, so it is considered to be a open circuit. Therefore whatever the potential difference across the cell will be appearing in the voltmeter, so the voltmeter reading will be exactly the potential difference across the cells. So therefore that is a very simple case, that is called the epsilon. But when you connect a high external resistance, say R, so what will happen? The circuit will be closed, so current I will flow through the circuit, so the voltage drop across this external resistance, and that will be V is equal to I into R. This is very important equation. This is according to the equation Ohm's law, right? So V is equal to IR. Now this value will not be equal to this EMF, this epsilon. In fact, the voltage V is equal to, right, because of this internal resistance of the cell R, this V is equal to epsilon minus I into R. This is equation number 2. Is it clear for you? So this is the voltage drop across the external resistance R, and that is represented as V is equal to I into R, and the value of potential difference shown by the voltmeter will not be exactly equal to the EMF, and that will be the EMF minus the voltage drop across the internal resistance. So now what we can say that this IR is equal to epsilon minus V. So this is the voltage drop across the internal resistance. Let it be equation number 3. So now when you divide this equation 3 by 1, so 3 divided by 1 will give you I into R divided by I into capital R is equal to epsilon minus V divided by V. So I is getting cancelled, therefore the internal resistance R equal to R into epsilon minus V divided by V. So from the value of R, epsilon and capital V, you can calculate the internal resistance of the cell. So it is very simple. When the resistance is not connected with the circuit, so in the first circuit the voltage shown by the voltmeter is, because it is a open circuit, so the voltmeter is exactly the value of EMF will be shown by the voltmeter. Okay, that is very simple. But when the external resistance is connected, current will start to flow across to the through the circuit. So therefore the voltage will be not equal to epsilon minus I into R, and the same thing is shown by this voltmeter, and which is parallel to the external resistance, and this will show this V is equal to I into R, that is Ohm's law. So comparing these two equations, we are finding the internal resistance is very important question. Hope you have understood this. And also if we calculate the power dissipation is current into EMF, and current into this EMF is IR plus V. Am I right? IR plus V. So you can write I square R plus, we know that already V is equal to I into R, capital R. So it will be I square R. See, so the power dissipation is two terms. One is power dissipated across the external resistance and power dissipated across the, across the internal resistance also. So our aim is whatever the power delivered by the cell, it should be exactly dissipated across the total resistance capital R, that is external resistance. But because of the presence of the internal resistance, we are dissipating certain amount of energy across it. So it should be avoided. So its internal resistance must be very, very less, and it should be negligible to 0, so that whatever the power is going to be delivered to the device or load, and exactly you can get this value. So we have to choose the cell whose internal resistance is very, very low. That's our motto. Yes, now let's go to the another important question. So இது ரொம்ப ரொம்ப முக்கியமானது. Cells in series and parallel. இதில் வந்து பார்த்தீங்கன்னா we have 1, 2, 3, 4 cells, identical cells. எல்லாமே வந்து பார்த்தீங்கன்னா all are epsilon, all are connected in series. So here cells series connection, here cells in parallel connection. That is a difference. So this is also very important. So you can expect this one in 3 mark question separately, but together we can expect in 5 mark question. First I will discuss a series connection. Renana, what is the total resistance? The total resistance is so we have four cells, and this can be n number of cells. So n into R plus the external resistance capital R, and according to the Ohm's law, the total current flows through the circuit is total EMF by total resistance. So total EMF is n times epsilon, we have n times cells, here we have 4 cells, divided by total resistance n into small r plus capital R. Am I right? Okay. Now I will discuss with the 2 cases. One is when R is very, very lesser than capital R, நம்ம internal resistance ரொம்ப கம்மியா இருந்ததுன்னா this could be 0 இல்லையா? So we can write I is equal to n epsilon divided by capital R, and this quantity is simply epsilon by R is taken as I1. So n times I1. So I1 ங்கிறது current delivered by a single cell. அப்போ உங்களுக்கு total current என்ன கிடைக்குதுன்னா n times the current delivered by the one cell. அதனால வந்து பார்த்தீங்கன்னா we can get more current in this circuit. And இன்னொரு கேஸ் வந்து பார்த்தீங்கன்னா case B is when internal resistance is very, very greater than the external resistance. இது அதிகமாக இருக்கிறப்ப என்ன ஆகும் அப்படின்னா, and this could be 0. அப்போ I will be equal to n epsilon divided by n into R. இது என்ன ஆகும், cancel ஆயிரும், and this will be equal to simply approximately epsilon by R, and it is nothing but I1. So இதில் என்ன கிடைக்குது அப்படின்னா, ஸோ எவ்வளோ செல்ஸ் தான் நீங்கள் வந்து கனெக்ட் பண்ணியிருந்தாலும் உங்களுடைய இன்டர்னல் ரெசிஸ்டன்ஸ் அதிகமாக இருந்ததுன்னா தி கரண்ட் டெலிவர்டு பை தி சிஸ்டம் ஆஃப் செல்ஸ் வந்து வில் பி ஈக்குவல் டு த கரண்ட் டெலிவர்டு பை ஏ சிங்கிள் செல். ஒரு சிங்கிள் செல் கொடுக்குற கரண்ட்டு என்னவா இருக்கோ அதுதான் நீங்கள் 100 செல் கனெக்ட் பண்ணாலும் 200 செல் கனெக்ட் பண்ணாலும் அதுதான் கண்டிஷன். ஸோ திஸ் இஸ் த கேசஸ் இன் சீரிஸ் கனெக்ஷன். But when you go to the parallel connection, what is the effective resistance here? For parallel connection is 1 by R, equivalent is 1 by R plus எல்லாம் identical தான் எடுத்திருக்கோம், plus etc. 1 by R. So எல்லாமே 1 by R தான். So this will be equal to n by R, ரைட்டுங்களா? So R equivalent parallel case வந்து என்ன வரும்னா R divided by N கிடைக்கும். So therefore your total resistance will be R by N plus R னு கிடைக்கும். Now what is the current is total EMF. Total EMF is epsilon. ஒரே ஒரு செல்லோட EMF divided by R by N plus capital R. Or you can say இது மேல போயிரும் N epsilon divided by R plus capital R. Okay, that's all. Yes, into N. R plus Rn. இதுலயுமே கேஸ் இருக்கு. When R is very very greater than capital R. இப்போ நீங்க உங்களுக்கு வந்து internal cell வந்து external cell விட ரொம்ப அதிகமா இருந்தது அப்படினா this could be 0. அப்போ வந்து உங்களுக்கு வந்து current will be N epsilon divided by R கிடைக்கும். இது approximately NI1 கிடைக்கும். So parallel connectionல situation is different. When the internal cell of the cell வந்து அதிகமா இருக்கிறப்ப நமக்கு current நிறைய கிடைக்கும். So I will be greater than NI1, you know very well. At the same time when R is very very less than capital R, R ரொம்ப கம்மியா இருக்கிறப்ப NN cancel ஆயிரும். This I will be approximately equal to epsilon divided by yes capital R. இது வந்து இந்த கரண்டோட வேல்யூ வந்து ரொம்ப கம்மியா இருக்கும். So என்ன கன்க்ளூஷன் அப்படினா சீரிஸ் கனெக்ஷனை பொறுத்த வரைக்கும் நம்ம செல்ஸ் வந்து நியூ செல்ஸா இருக்கணும். parallel கனெக்ஷனை பொறுத்த வரைக்கும் செல்ஸ் வந்து கூடமான வரைக்கும் ஓல்டு செல்லா இருந்ததுன்னா நம்ம கரண்ட் வந்து நிறைய கிடைக்கும் அப்படிங்கறதா பாயிண்ட். when R is very very greater than R, we are getting NI1. So this is the comparison of cells in EM series and parallel. இன்னொரு முக்கியமான ஒரு क्वेश्चन வந்து என்ன அப்படினா Wheatstone bridge. ஆக்சுவலா இது வந்து பேசிஸ் ஆஃப் Kirchhoff laws இல்லையா? இந்த Kirchhoff laws or Kirchhoff laws எப்படி வச்சுக்கலாம். இந்த Kirchhoff laws Kirchhoff rules பேஸ் பண்ணி தான் நமக்கு வந்து இந்த Wheatstone bridge இருக்கு. ஸோ ஆக்சுவலா Kirchhoffோட ஃபர்ஸ்ட் லா என்ன அப்படின்னா K1 ரூல் என்ன அப்படின்னு பார்த்தீங்கன்னா algebraic sum of current meeting at any junction will be equal to 0. அதே மாதிரி Kirchhoffோட செகண்ட் ரூல் அதாவது வோல்டேஜ் ரூல். ஸோ இது வந்து algebraic sum of current in any branch of the closed loop will be equal to algebraic sum of EMF present in the circuit. So this is what your Kirchhoff first rule and second rule. இது ரெண்டையும் பேஸ் பண்ணி தான் இந்த Wheatstone நெட்வொர்க்கு. இதில் வந்து ஃபஸ்ட்டு நம்ம ஜங்ஷன்ஸ் எடுத்துக்கிறோம். ஸோ ஜங்ஷன்ஸ் பிலையும் டிலையும் நம்ம என்ன பண்ண போகிறோம்னா Kirchhoffோட ஃபர்ஸ்ட் ரூலை யூஸ் பண்ண போகிறோம். ஸோ இதில் இன்கமிங் கரண்ட்டை ப்ளஸில் எடுத்துப்போம், வெளியில் போகிற கரண்ட்டை மைனஸில் எடுத்துப்போம். ஸோ I1 மைனஸ் IG மைனஸ் I3 will be equal to 0. Am I right? So இந்த கரண்ட் ப்ளஸ், இந்த கரண்ட் மைனஸ், இந்த கரண்ட் மைனஸ். அடுத்த ஜங்ஷன் டியில் எடுக்கும்போது I2 this will be plus, IG plus, I4 minus. So I2 plus IG இந்த ஈக்குவேஷன் எழுதிட்டாவே உங்களுக்கு 1 மார்க் கிடைச்சிரும். minus I4 that is equal to 0. Then Kirchhoffோட voltage rule யூஸ் பண்றங்க for the closed loop ABCDA க்கு நீங்க யூஸ் பண்ணீங்கன்னா you will get I1P then minus plus IG into G minus I2 into R is equal to 0. Then we go for the another loop. So இது வந்து ABDA தான், ABDA. I mean இந்த first இந்த போர்ஷனுக்கு ABDA க்கு நம்ம சொல்றோம். Then when you go to the whole loop ABCDA போனீங்கன்னா when you go to the ABCDA what will happen? I1P plus I3Q minus I4S minus I2R that should be equal to 0. So condition use பண்றோம் when the junctions B and D are at same potential. So current flows through the galvanometer will be equal to 0. So IG equal to 0 போட்டீங்கன்னா what are things you can get? I1 is equal to I3, then I2 is equal to I4 because this will be 0, this will be 0. So you will get this one. You will get this one. And as far as this is concerned, I1P and this will be going to 0. So this will be equal to I2R. I1P is equal to yes. Now very simple thing we are getting. So I1P is equal to I2R, and here when you substitute instead of I2R, when you substitute I1P, you will get I3 in this equation. I3Q is equal to I4S. இப்போ இந்த ஈக்குவேஷன் டிவைட் பண்ணுங்க. I1 yes, இங்க I1P and we can retain this P and yes, of course, I1, I2, I3 is equal to I1. So you can get this one I1Q, I4 is equal to I2. So this will be equal to I2. Yes. Now you can divide. I1P divided by I1Q is equal to I2R divided by I2S. Okay. I1 cancel, I2 cancel. Therefore, what you are getting, P by Q is equal to R divided by S. That's all. This is the balancing condition. When this condition is satisfied, automatically the junctions B and D will be maintained at the same potential. Therefore, the current flows through the galvanometer will be equal to 0. And this condition is called the balancing condition for the Wheatstone's bridge. Based on this theory, we have meter bridge. Isn't it? Meter bridge. In meter bridge, the same configuration, this divide is used to find out the unknown resistance, and in that we have P by Q is equal to L1 divided by L2. So based on the same thing, in terms of balancing length, we can find the unknown resistance and also resistivity. So these are all the very important questions as far as the current electricity is concerned. My dear students, tomorrow I will explain some of the very important questions in the remaining chapters. So you please go through that video also, and that will be very, very important. I will try to cover the chapter number 3 and 5 tomorrow. Then I will tell you what are the questions or important questions particularly for 5 mark. So keep in touch. Thank you so much. Please share your friends and also subscribe the channel. Thank you so much.